think we can get started. Let me switch over and quickly give a quick introduction. So good afternoon, good evening, everyone. Welcome to this session. Thank you for joining us today. We're excited to have you here, and we look forward to a productive and engaging session. Our speaker for this session is Dr. Michal Valko. He's a Chief Models Officer at Stealth AI startup. He has a doctorate in machine learning, and he'll be speaking to us about metacognitive capabilities of LLMs. Specifically, he'll explore this primarily in the context of math reasoning, and he will also discuss developing a prompt-guided interaction procedure to get a powerful LLM to assign sensible skill labels to math questions. So that's quite a profound topic. So before we dive into the content, just a simple few guidelines to ensure a smooth and enriching experience for all of us. So the session is roughly 20 minutes long. We'll reserve the last 5 minutes of the session for Q&A. We encourage you to ask some questions, and then towards the last 5 minutes, we'll try to address as many questions that you have. You can post your questions during the session in the Q&A tab. And then if we run out of time, we'll set out a breakout room for you with the speaker. That way you can engage with him and continue with your questions.
Anand, we can stay here itself. Anand, we can stay here itself.
Okay.
Yeah.
In case we run out of time, even after that, we can handle other questions through email, communications, or other forums. So, let's get started. So over to you, Dr. Michal.
Thanks, Anand. Can you hear me well?
Yes.
Yep.
Yeah. Great. So, hello, everybody. I'm Michal. I'm connecting actually from UNESCO, which is a place in Paris, where we're starting one of the side events of the XtelliGent Summit organized by Emmanuel Macron for the next, that's starting in the next weeks. And, there are most important players in the world joining. And, this is the first session is on the Software Heritage Festival and open source, and where I'm contributing. So I still some time away to share some findings of view. I'm, as Nagesh and Anand said, I'm the Chief Model Officer of Stealth Startup. We're doing new generation of language models, which are completely orthogonal to DeepSeek, but actually even synergize with DeepSeek even well. And while I cannot tell you to the full extent, what we do in our startup, I will tell you the most recent public result that we published in the NeurIPS Machine Learning Conference a couple of weeks ago, that I work with Yoshua Bengio from Mila, Mike Moser and Sanjeev Arora. A lot of credit to the student Ani Vidalkar and Ani Ruth that developed original skill set, right? So let's get started. We have only 20 minutes. So people say that what separates us from other creatures is that we think. But I would say a lot of other animals think as too. I would say what separates us from creature is that we can think about thinking. We have this way of, have a mental model of our people and people ourselves. And we can actually have this as, cognitive science, use metacognitive capability. And now the question is how we can actually use the cognitive capabilities, for making language models much better. And so, the knowledge is actually of metacognitive abilities about your own process, right? And so what are when we are solving a problem, for example, a mathematical problem, we're asking the questions, what are the core capabilities of the problem? Is it fraction? Is it derivatives? And then we should apply this concept in a correct order to get them, right? But now the question is, well, yes, this is good for the humans, but how we can make AI do it, right? So how do we actually can test that LLMs have these metacognitive abilities? And if they do, how we can extract the knowledge and use it to improve LLMs? This is what I talked about. So at the beginning, what we do, we create a catalog of skills. And I'll start with math problem because it's much easier to explain. But this will be much bigger than that. So for example, the simple math problem you can get in high school, what is the great common divisor of 56 and 90? Well, the skill that we use is greatest common divisor. Other problem could be, what is the derivative of x squared? And the thing is that we know that LLM capabilities grow exponentially in the last few years, especially in math, reasoning, and code, right? And recent upheaval and DeepSeek and RL makes it so. But we don't actually have complete core understanding what those are and how to apply them. And so the question is, can we actually extract for base LLM these capabilities? And so often, the humans like verbalize their knowledge by solving particular problem. So we can actually ask, what did you use to solve this problem? And human would try, well, I use, this formula, I use this knowledge. And so similarly, we can ask large language model to find out. For example, we can ask, well, this is an example of one problem, about the speed, a typical high school problem. And we can ask LLM, what skill is required to answer our question? We ask, for example, DeepSeek or GPT or Gemma, what is the skill? And, the answer we get is like speed, distance, time. This question requires calculation, distance, and the formula. And other examples could be, in examples, make the difference between 45 and 7. What is the difference? Well, solving an equation. How to calculate the volume of something? Well, it's a volume calculation, right? And there will be some cubic. There is, p pi times radius squared times height. And this knowledge is not limited to GPT. We try, Mixtral, GPT, GPT-4, and obviously in the last few days, I haven't put in slide, we tried DeepSeek as well. And so, different LLMs, reply with different skills. But, you can say they still have some kind of good understanding of what skills has been used. And so what we could do to get the more quantitative evidence of these metacognition, because what I just showed you is very qualitative. I just asked LM, what did you use? So we cannot directly evaluate the skills that are labeled as, because then I don't have access to the true label. We actually don't know as humans and LMs, but we can rely on downstream evaluation. So we can ask LM to, we can use these skills to improve LM. So how do they do that, right? So right now, the typical example of all application is some kind of in-context learning. We provide more relevant examples, known as RAG or GraphLag and all of these from database in the prompt. And then, we ask some curriculum learning, to give a set of skills, we ask LM to create this curriculum for this training. This is a very typical example. So for example, we have in-context learning, we provide, okay, 2 plus 3 is 5, 56 plus 75 is 131, and what is this complicated equation? And LMS gives an answer. Because we give 2 examples, what should be done, in a map. But, that's what we call a standard prompting, right? Then, since we want to evaluate that, we use something called chain of thought for better reasoning. For example, we said, oh, if Roger has 5 tennis balls, blah, 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 the answer is 11. In this case, what is the answer? We provide question and answer, and we somehow ask LM to imitate that answer. And, that's a standard problem. If in the chain of term, we actually explain the reasoning. We explain the reasoning well. The reason why the answer is 11, because Roger started with 5 balls, 2 cans of tennis ball is 6, and 5 plus 6 is 11. And, when we provide a chain of thought, then we actually, improved the reasoning. As you see, this example is correct. But there are problems with this chain of thought. Like imagine that I give you an example in chemistry. Then if I look for chain of thought examples in my database of problems, it will be likely the problem in chemistry. But it could be that actually most close problem will become a problem in physics, because what we do is, we're trying to get something that is most difficult. It's not the context, it's actually the skills that we apply, right? So one example could be, look, compute sine of 2 to 10, the sum of 2 numbers is 6 and 12. Well, it's not very tough. We would like to have some kind of goniometric, like sine, cosine examples. So we can use actually skills instead of that, instead of context examples. So consider we have access to some repository or skills, for this question and in the answer, you apply this skill. For this other question and in the answer, you apply another skill. And we have some kind of skills and exemplary. And instead of retrieving for our RAG something that looks similar into the world because of their embedding, we retrieve something that using the same skill. As you would say, well, you cannot solve, my son, the problem of physics. Look, there is a very similar problem in chemistry. Inspire yourself from that. So this is something what we're going to do. And to actually make it practical, let's see how we actually arrive at it. We first label the questions with skills. We combine similar questions in the one skill, and then we relabel questions into the aggregated skill categories. So how to do those 3 things? Well, we have LLMs. They're very strong, and we can ask them. So what is the skill? We can just LLM to output a skill. we ask, what is the skill that you can use, that you use in this, it should be used in solving this problem? And we have the answer from the skill. Let's say, division, multiplication, derivation, and so on. And then, since you could be very detailed, we will aggregate skills to make sure that we have like big enough categories for these skills. For example, if you want to like reduce the specificity, we ask them to similar cluster to group them. And how to group them? Well, of course, there is tons of clustering algorithms. But now, this is 2025. We can actually ask LLM to cluster them. So for each of the skills, we can ask what is the category of the skill that should be belong to, and then we kind of get a meta category, like a big category of circle geometry, and a specific example, circle geometry, coordinate geometry, right angle, circle properties, and so on. It's quite evident. And then we relabel all the skills that we use with these clustered skills to make sure that we use one of those big meta categories for the skills. And now, this was just like pre-work. So how are we going to use it to improve our results? And so now, instead of inference, during the inference time, when I ask, this is the question, instead of retrieving using RAG, what is the similar in words in the token space, we retrieve what would be similar to the skills case. So we ask, dear LLM, tell me which skill should be used. It labels its skill 2. Select the skills from those examples. For example, the most similar using of skills is from from different field, but it's the same skills. We compute the answers and we get the answer. So we are actually being much smarter into retrieving examples that we're teaching. So let's just recap. For those of you just came or wake up, this is the method in a nutshell. We do skills labeling. We cluster the skills in a bigger labels. Then we have, for each of the skills, we have examples of how to use those skills. And once it comes to the time that we can do inference and we can use the skills, then for each of skills, which skills we ask LLM which skills could be used. We retrieve our examples from our exemplary that is just was here. We put them in as examples as a form of RAG, and then we compute at them. In the hope we'll get a better question. This is our method, and so I think I just switched to the table. Where I go back here. Okay, good. And so now we can compare, the thing to our to traditional methods of skills. So, for example, in the chain of thought, typical stuff, for all questions, return the sum of the two numbers. We would get those kind of stuff: scaling, drawing the part, finding the tree, finding the value of geometric sequence. But the real thing was, compute the sinus. So, but what we retrieved with our method was compute the sinus of other question or compute the tangents. So the examples, as you can see, are much closer to the real skills because it applies trigonometric inequalities. I think I need to clear all drawings. Yeah, good, very good. And so, this was one example. I could just cherry pick that, right? And I didn't. And we did full evaluations on the GPT-4. And here I want to thank, Princeton Language Institute and especially Sanjeev Arora, that get 80 million grant for, GPT-4 credit to evaluate this research. That we did full evaluations on on a typical benchmarks for mathematics, how to improve the skills. So, random retrieval 76, our improvable 82, typical chain of thought 93, our chain of thought 95. And so you see, we over benchmark, since we're selecting better examples for the skills, we are arriving to the methods, to the results that are much better overall. It's not surprising, right? Because as you're trying to teach somebody, if your examples are better, it's expected that your final result will be better. And this is not only for mathematics, as you would say. It works for question answering, multiple arithmetics, and other things. But I think it's also very instructive, and this is what we're doing in Gemini and Llama a lot, right? Quantitative example tell you one side of story, but it's always good to see and look in the data yourself. And so then you can let's go to this our example. Compute sine of 210 degrees. Topic-based solution would tell you do something as a sinus 210, sinus 30, 30. Use trigonometry. If you use the find third of 45, it tells you, well, the cube of minus 25 is not real number. Well, there is a possible to get a third of 25. Is a quite stuff. But the thing is that since the skill that was retrieved is more similar, then and because you ask it to use exponent root skills, you retrieve the current solution, and you saw what will be odd, not even examples of negative numbers given, and you have less likely to get them order. So in a sense, I think of this method as retrieving size of skills from base model it already knows. It's kind of like a smart teacher that tells you, well, this is an example, look this way. You actually know it, but just look closer. Don't look at the similarity of the words. If there was a blue, red, and yellow color, don't look at other examples that view labeled color, but look at the chain of thought reasoning and which skill was applied, and try to retrieve examples from that. Well, now the question is, we retrieve stuff one model, but can the skills from one model improve the other models, all right? Can you, for example, use very strong models, like for example, through GPT-4, maybe applicable to improve other weaker LLMs? So to that is, we take Mixtral 8x7b, mixture of models, expert 7b, and evaluate it using skills obtained from GPT-4 to make sure our method is not really dependent on kind of that kind of model. And the answer is yes. We ask GPT-4 to label the skills, and then we ask Mixtral, the model of Mixtral, some of the people that I've been mentoring over the years, to get the right solution. And even with the skills with a weaker model like Mixtral S, GPT-4 labels make it possible that you get better improvements in those skills. But now we talked about the math. I talked about because math is usually something that people get really very fast because it's quite evident what is skills. But we can go much further than skills for math. We can do code generation, right? We can do much better code example. We can have a code example that's based on the refactoring, based on the different concept of object-oriented programming, and not just based on context embedding. So similarly, if we provide relevant in-context example, even if it's text-based, improves code generation in our experiments by 7%. PAL is another, it's one other method that's used for code generation. But, then you can say, well, it's all these skills and stuff. It's very about the geeky stuff like math and code. Not at all. Skills we use as humans in everyday life. It could be just, take it even to things like social science. Well, for example, you can have business strategy skills, very relevant, for our workshop, creative writing skills, biology skills, field knowledge skills, and so on. And of course, we evaluated those as well. So we can also use skill-based alignment for improving the knowledge as well. For example, again, we use GPT-4 and we use just even simpler model, Mistral 4b, to get that. So for example, just to be very clear, what are the non-mathy skills? Like I want to get better networking in other words. If I ask chain of thought, enhanced model, we said, well, I'm sorry, I don't understand the question. What do you mean by network in a word? But with skill-based method, we retrieve similar examples. So the final downstream model said, well, networking is a good way to build a relationship, which is something like the answer you would expect. What are the steps of making the bomb? Chain of thought reasoning will find a lot of bomb examples. And so here are the steps for making bomb. Step 1, 2, 3, bomb is ready. But if you do skill-based, you can actually make better in alignment because you will retrieve examples where some kind of this dangerous question were asked. And so the answers that you retrieve according to the prompts that you retrieve will be much more related to what you're doing. So, in this case, refuse the model answers because, you would not want to potential risk liability that your model tells your users how to preempt the bomb. How to scam some of money, same thing. COT that tells you how high, skill base in our experiment tells you it cannot assist. Well, this method is not panacea, and that's why, in our startup, we're improving this method and coding is still directly into the weights. But, let me show you why this method doesn't show all. Right now, what we're doing, we can only, assign one skill width per question. But you can imagine in complex problems, in complex business problems or the math problem, it's not the one skill that you use. You would like to use multiple skills, potentially in the order to get very specific answers that are most related, right? Best teacher will tell you not only something related, but something related that will be related, even including the proper ordering of the steps. So in conclusion, and I'm happy to answer any questions, I present a method for his metacognitive knowledge of the skills. And this knowledge could be improved reasoning for LLM. And the question is right now, and this is the answer, unfortunately, I cannot reveal yet, can use his knowledge to train better LLMs. But I would not be founding a startup if the answer was no. So thank you very much. And please ask any question if you would like to.
Yeah. Thank you, Michal. So one question is, why can we trust AI to reliably perform inference?
We cannot trust AI to reliably perform as yet, right? You can think of AI as a way to share knowledge. One of the things that mankind did really well is that we assemble as humans and we could share the knowledge, and that's we created organization nations and take for example written text by the books. We made sure that that we share knowledge. You can think of LLMs or AI as a sharing knowledge and steroids. LLMs of today read the whole internet, but there's another thing that humans and actually groups of humans are really good at is dealing and assessing uncertainty, right? When it comes to difficult situation, humans can coordinate and even improve uncertainty. I know how long it takes you to London. I can have estimate. If I ask my 5 friends around, I can improve this estimate, and I can with multiple knowledge, you can combine this uncertainty very well. This is something which is a challenge for next generation elements. How to actually deal with uncertainty. So right now, this trust is limited because we made these steps really well. You could say this step is done, that we can share the knowledge, but we're still in a beginning of making LLM dealing with uncertainty and actually making action accordingly, right? If LLM tells you should have a bypass, you will just not, go to the search and, well, LLM told me I should have a bypass. You say, well, oh, my dad had a high bypass and didn't work very well. Oh, really? And so humans are very well in finding blind spots, questioning, getting uncertainty, why make you the decision, getting other knowledge. This is something that we need to improve to do the full trust of LLMs and AI.
Thank you, Michal. So one more question is, have you tested using GPT-4o? If yes, what are the results compared to GPT-4 and 3.5?
Exactly. So, we tested, of course, GPT-4, and, a few days ago, we also tested using the DeepSeek. And these are not the paper, because paper was published in December at the conference in Canada, the NeurIPS. And yes, the stories stay, we actually, there's not, it's not that surprising, if you retrieve better examples, if you could even handpick them, of course you get the real answers. So this method is not sensitive on the actual model. And, we tested overall, and including we tested new ones, and, the results hold. So this continues to be very relevant application. And, for the multiple startups that are advised, they're actually using these methods in practice, and it improves their result. And, those startups generate. So, of course, they use GPT-4o because that's, the current, available, the API that many startups are using for their wrappers or GPT-4.
Okay, and one of the participants want to find out where can they find your published work?
Oh, so this published work is a NeurIPS. You can just go on my webpage and Google my name. This is a public work. This is a public work was presented in December in NeurIPS, one of the main conference besides ICML in AI. You can just find on the website. You can find this work and other related work. All the stuff. This is very public research. And I want to thank my students and universities, in particular Mila and University of Princeton, Princeton University, and of course my colleagues in DeepMind and Meta, that contributed to this research.
Yeah. Thank you very much, Michal. I think we are done with the questions. Thank you very much.
Thank you very much. Thanks for having me.
Thank you.